This might just be one of the most technologically advanced 3D printers ever made, and today we're going to be taking a look at all of the incredible things it's capable of creating. Before we start unboxing this machine, I'm going to quickly run through some of the most important specs. The Bambu Lab H2D has a build volume of 350 by 320 by 325 millimeters, technically. Because this machine has two nozzles, there's a bit of an exclusion zone where the left or right nozzle can't reach, so individually the nozzle's printable area is 325 by 320 by 325 millimeters. They're both equipped with hardened steel nozzles that can reach 350 degrees Celsius, the bed goes to 120 degrees Celsius, and it has chamber heating with a max temp of 65 degrees Celsius, so you're equipped to print basically any type of filament you could possibly want or need. There's also two new types of AMS units, the AMS2 Pro and the AMS HT. We'll be getting into more specifics about these later in the video, but just know that both include filament drying capabilities. But the most notable thing about the H2D is that it's designed to be a personal manufacturing hub and not just a 3D printer, so it's also capable of digital cutting and laser. If that's not your thing, not to worry, because it also comes in two versions, the regular H2D and the laser edition. I know, for a quick rundown that was still pretty long, and I've done my best to condense this video as much as possible while still being as thorough as I typically like to be, so this is just a little reminder that I always add chapters to these videos if you want to jump around to a specific topic or part. But anyway, back to getting this printer out of the box. This machine was very kindly sent over by Bambu Lab for me to test out early, but you know how we run things on this channel. I always just want these videos to showcase what these machines are capable of helping you create. And this one's gonna be a doozy. So after you almost die trying to get this extremely heavy printer into your workshop and then remove the plastic bits and top section of the cardboard packaging, you're left with this open section that you then have to remove even more packaging from. There is this supply box on top that we will be looking into later. There's another sheet of foam before you're greeted with some more instructions to tell you how to appropriately get the physical printer out of even more of the packaging. I tried to get rid of as much of the excess plastic as I could so that it was easier to grab onto. The box is actually designed to have like hand slots that you can more easily grasp it from the bottom to then be able to move it. So excellent packaging design there. Now that I have the machine on the table I want to set it up on, I started by looking through the quick start guide, which, you know, generally a good place to start. With this being a fully enclosed machine, there really isn't a lot in the ways of assembly. It's mostly just removing packaging. Started by very carefully removing the glass top from the machine so that we can get onto the inside of this printer where all of the accessories are stored, within plenty of foam. Here's a better look of the inside now that all of that foam is removed, and the first thing that we're going to need to do is remove this AMS unit that is bolted inside the machine for safety during shipping. And to do this, we're going to need some tools, and the toolkit is located in this accessory box. There's a lot of great stuff within this little tool package, but the thing that we actually are going to be needing is the longer of the two hex keys. All of the bolts that need to be removed are pretty visibly labeled by circular red stickers around them. The most visible are the 4 bolts on the bottom of the AMS unit that are facing towards the open door, but there are also more tucked in along the sides that are kind of difficult for me to show you, but there is one either side on the top, and when you've got those removed, you'll be able to take off these plastic brackets and then actually fully remove the AMS unit from within the machine. There are even more things packaged within the AMS unit, but we will be dealing with that a little later on, because first we still have 4 more screws to remove from the bottom plastic section. Again, they are labeled by those circular red stickers, and once those are removed, you'll be able to remove that plastic bracket as well. Next are removing the bolts holding the bed down during shipping. They're once again pretty visibly marked by some red stickers, and when you have those removed, there is still some more packaging to be taken out of this machine, some more foam, these zip ties that are all around the hot end, even more foam that I had to move the hot end away from to be able to sneak out of the machine, and then lastly there are some stickers within the machine itself and some other little foam bits that I was finding here and there, like tucked up within the corners of the printer. And once I felt like I'd finally removed all of the foam and other packaging from within the printer, it was time to finally get the glass door out of its cardboard and place that on top of the machine. It's a bit hard to tell here, but this glass is actually like solid black. It's not just like a camera trick or something. And with the glass top installed on the machine, I now have a good spot to open up this AMS unit. The majority of the things packaged within this AMS unit are more specifically for the laser edition of of this machine. You've got a vent housing and some hosing, other laser related accessories. The things that should be the same though are all of these PTFE tubes and the silica packs. Removed even more packaging, and I'm sure you're all going to be thrilled to see that the PTFE tubes are exposed on the bottom of this new AMS unit. So no more having to unscrew half of the AMS to do any sort of maintenance. Next, I took the silica packs that are packaged in the back of the machine, took them out of their like over wraps, and then placed them back where they were packaged so that they're all now good to go to dehydrate this whole enclosure. But then it was on to connecting this AMS to the machine, starting with these PTFE tubes. There is one significantly longer one and then a shorter one. The longer tube you're going to want to connect to the top inlet and then into the back of the AMS unit. I then went ahead and connected the cable from the back of the AMS to the back of the printer. The next piece we need you're going to find in the accessory box again underneath the cutting module, and that is the external spool holder. Now I really did not do a great job at filming this, but you basically just sort of like slide it onto this little clip thing and then it kind of sits on the side like that, and from there you then plug in that smaller PTFE tube from the bottom inlet to then this connector that's part of that external spool holder. And here's what the back of the machine was then looking like. You can see there's actually a TPU specific filament inlet. That's a very cool feature to have that you might be seeing later on in this video. You have the back vent, which the vents are closed on it right now, and then at the bottom there is the safety key that you need to remove and then plug in to the key outlet. This is a feature added because of the laser functionality, although both versions of the machine should have this. There's also this screw on the back that needs to be removed, again pretty visibly marked by a red sticker, and all that's left after that is actually plugging in this machine. Before continuing on with setup, I just wanted to go over the other things that were still in this box. Starting off with the accessory box, we have a pack of the filament swatches. Underneath that there are a couple of these markers that actually go along with the cutting module that was also packaged in this box, and then lastly we have the emergency stop button. We will be opening up and delving deeper into all of these things as we get to them throughout this video. Next up is the supply box. On top here we have this bag that includes some accessories and materials we can use in the machine. Then underneath the cardboard we have the laser platform. This is pretty much like a printer build plate that is equipped with the slat holes to then put the slats into for laser cutting and engraving. Underneath that we have another little sample pack of materials we can use with the machine. And last thing in this box is the cutting mat to be used with the digital cutting module. Now let's get back to setting up this machine. Once it's being powered on, you're met with the fairly typical setup steps. Select your language, region, connect it to your Wi-Fi. More specific would be logging into your Bambu account. It then brings you to a screen to remind you to remove the 4 screws holding the bed down if you hadn't already done that. It'll then begin its 4-step calibration process. It starts off by homing the build plate and then just sort of moving everything around and testing to make sure everything is running and connected properly. You can see it flipping the nozzle here. It is probably doing somewhat of a nozzle calibration, but after that it then starts into its first phase of auto bed leveling. Nothing super special to report here, it's just going across, probing the entire build plate as it generally would do for auto bed leveling on any 3D printer. After that it was on to the motor noise cancellation, which is where the machine will move the motors back and forth at various speeds and frequencies. And the craziest thing about this is you can actually hear the noise cancellation taking effect and improving the sound of the machine. Next up is vibration compensation, which helps to improve your print quality and stop any vibration artifacts from appearing on your prints. It never looks like the machine is doing much, but it always sounds crazy. Next was the second phase of the auto bed leveling. I believe this actually did heat up the build plate, but it then also decided to probe the bed using both of the nozzles. Lastly was the nozzle offset calibration. Pretty self-explanatory. The machine is basically just figuring out exactly where the nozzles are in relation to each other for the best possible print quality. And that concludes the calibration. If you've plugged in the AMS, it will prompt you to set that up as well. You can literally just manually do it and tell the machine which nozzle the AMS is connected to, and once that's there, you can see from the menu how you have the drying options for this AMS2 Pro unit. I don't know where else to mention this, so I'm just sliding it in here. The most visible difference between the two versions of the H2D would have to be the green laser safe windows on the laser edition. The green is to block the UV light from the laser when you're using it, it. Very critical safety feature. You can see the difference here, but I just had to mention it because I'm sure if I didn't address it, the green coloring would start to confuse people. There are also a few slightly more advanced calibrations that you can choose to run the machine through, so I'll be showing you those next, starting with what is called the high precision nozzle offset calibration. And you can probably guess what this one is going to do, but this test has you loading in 2 contrasting filament colors, so I loaded some white into the left nozzle and some dark brown into the right. This test is a quick little print job that uses each color in each nozzle for the machine to then scan and I guess measure and check that everything is touching and lining up as it should. And that is why you want to be using those contrasting filament colors so that the machine can accurately tell the difference between them. Here's what the print test actually looks like. The upper object is just a bit of a purge tower. Next up, we're going to run through the motion accuracy calibration. This test uses this additional accessory called the vision encoder plate. And when you look closely, you can see this thing is covered with a bunch of really tiny QR codes. After placing the plate onto the printer, the machine will start to move and scan the plate in 50 micron resolution optical measurements, which I'm sure I probably don't need to tell you is very small and super precise. These measurements should end up helping the machine achieve 50 micron motion accuracy, and that combined with the temperature controlled chamber and various algorithms means extraordinary fit accuracy for parts. For the first print, I really wanted to do something that used both nozzles so we could see exactly how this technology works, and what more obvious way to display the differences between nozzles than with some black and white filament for a big Clone Trooper minifig print. When you go to slice multicolor prints, you can now choose how Bambu Studio handles the filament grouping, and it gives you a readout of how much filament you're saving by using the 2-nozzle system over a single nozzle with AMS. And even for this reasonably small helmet print, the savings were incredibly noticeable. And not even just for filament saved, but also time. On average, each filament switch takes at least a minute and a half, but the nozzle switching is obviously much faster. How fast though? Let's time it. Yes, that was a grand total of 7.06 seconds. Now, occasionally the nozzle will choose to wipe itself off, so when that happens, it will be a little longer than 7.06 seconds. But either way, it is still significantly faster than the minute and a half plus that the more traditional color switching method takes for just using an AMS system. One thing that I do just have to mention though, the sculpt of this file has some texture, looks a little rough in spots, and this printer did a fantastic job at capturing all of that, of course. So the roughness you see on this print job is just the printer accurately capturing the model and not any printing defects or artifacts. Overall, it still looks pretty great though. I was also very interested to see how the H2D handled this torso piece because it's actually 3 colors. When it got to that section, the right nozzle, which is the side that I have the AMS connected to, went through a typical filament changing cycle. The machine cuts the filament, purges the excess, unloads the first color, loads the next, and then purges a bit of that filament before starting to print again. You could also add primes the nozzle on a purge/prime tower to that sequence of events, but I didn't bother using one of those for this print job since it was pretty simple. So yeah, when you go beyond the 2 filaments, 1 in each nozzle, you're back to the typical AMS color change situation. I do think the dual nozzle setup will still frequently save a lot of filament and time though. A lot of multicolor prints have a dominant color, and the machine only having to switch for the accent color, say, is going to be decent savings wise. I had a bit of support failure for the 1 arm piece, so I reprinted those, printed the last bit of all black pieces, and then started assembling. No glue needed for any of these parts. It literally goes together like a giant Lego minifig. Such a fun print. There are so many variations of these giant minifigs out there, so I might have to go ahead and print even more sometime. But for now, this Phase 1 Clone Trooper is looking pretty awesome. After that was the period of time I like to call use the machine for whatever you need in the name of putting more print hours on it, but also for testing purposes. First up was this super cool layered wall art. This worked as an excellent first layer test because I basically maxed out the bed with this one and the machine put down an absolutely flawless looking first layer. Yeah, a lot of straight lines on this one, but they were all looking really clean and it's just a very impressive looking art piece to display. Next, I fell down a bit of a musical instrument rabbit hole. Listen, I saw the file for one of these recorders and I just had to know how well a 3D printed recorder would work. I decided to use some of this really awesome looking transparent aqua PETG for it, which first print did have a failure that the cameras successfully automatically detected, so I just reprinted that one piece, which was by far the tallest, and second time worked perfectly. I guess just a bit of bad luck with that first one. And here is what this recorder, or space flute as the file is called, looks like put together, and what it actually sounds like. Yes, definitely a bit pitchy, but honestly more than anything, I'm just impressed that it worked. So I went ahead and printed this more traditional flute style instrument. It does come with an extra mouthpiece to help anybody play, but bit of a random fact, I've been playing flute on and off for about 15 years, so we're just going to go full force with this one. This one I do find to be more pleasant sounding. I am interested if printing it out of a different material would change its sound. Listen, I don't fall down my rabbit holes by half, and this one was by far the most intriguing instrument to me because it is a compact bass clarinet that uses an actual clarinet mouthpiece. So I was feeling pretty optimistic that this 3D printed instrument had the potential to sound pretty great. And out of this Galaxy PLA filament, it looks pretty cool too. I do feel like this one has a pretty great sound. It is like playing the bagpipes though. I cannot explain to you the effort that it takes to get like 3 notes out of this thing. And the finger holes are also kind of far apart, so it's not the easiest thing to play, but I am still glad I printed one, and hopefully I will eventually be able to play this a lot better. While the instruments were a fun side quest, it did get me thinking about pushing the limits of what 3D printing is known to be capable of. And 3D printing your own shoes seemed right up that alley. Especially considering I wanted to use one of the most notoriously difficult filament types to work with, TPU. You can see that it's almost like trying to print with plastic spaghetti. The file was designed to be a larger shoe size than I am, so I calculated out what percentage I needed to scale them to. I also decided to break into the AMS-HT because of one specific feature that's going to be very helpful for this project, the filament bypass path. It's designed to help with any filaments that wouldn't typically like the feed resistance through an AMS unit, so absolutely perfect for this soft TPU, especially when you combine it with the TPU inlet that is built into the H2D. There are literally instructions stuck to the back of the printer on how to set it up, but all you do is remove the PTFE tube from the right nozzle, so that ends up being the upper one, and just sort of sliding that into that back inlet. I also disconnected the PTFE tube from the hot end for easier filament feeding. From there I started feeding the TPU into the inlet until it was sticking out of the other end of the PTFE tube. I then grabbed the TPU and helped feed it into the extruder. Because TPU is so flexible, you really won't be able to push it into the hot end for the extruder gears to grab onto unless you're doing it really closely to the tool head like I'm doing here. Once you feel the machine grab onto the filament and start extruding, you can then reattach the PTFE tube to the tool head. Now it's really important to position the filament to have the least resistance possible when feeding into the machine, so that is why this extraordinarily professional setup ended up becoming a thing. I also decided to apply some glue to the build plate. It just seemed like a good idea to do. I've never actually used TPU before, and this was honestly a pretty risky print. So at the very least, the glue was going to help keep the TPU stuck to the build plate, at least hopefully, but it also creates a barrier so that the filament doesn't stick too much and damage the plate. These were absolutely wild to witness printing, just like the gravity-defying nature of how they were set up on the build plate, and the fact that this was actually turning out successful in one of the hardest to print with filaments was blowing my mind over the multiple days that this print job was running, because you really cannot be printing at super high speeds with TPU, so both of these shoes did in fact take 4 days and 2 hours to complete. And you know me, I don't typically do any of the recommended test models or display models or anything, but these shoes were just way too cool to not try out, especially in this gradient filament. One thing I did just want to mention is it's generally recommended to be printing these using a 0.6 nozzle, but I did change the settings to just use the standard 0.4 nozzle. So some areas might look a little rougher on mine, especially on some of those super steep overhangs, but moment of truth in figuring out if I scale these correctly, and thank thankfully these fit perfectly and honestly surprisingly comfortable shoes. The TPU gives them a nice flex and bouncy feel, and also the design helps with that as well. Genuinely, I feel like I would be able to wear these out and be comfortable in them. If anything, I just would not want them to get dirty or destroyed at all, and that would be the one thing holding me back. They do have lace holes if you want to add laces, but these were fitting me pretty well and not like falling off of my feet or anything, so I didn't decide to actually add laces to them, plus they just looked pretty cool as is without the laces. I think we can classify this as an extraordinarily successful first TPU print. Since I had a bit of that TPU left over, I wanted to try printing something else, so I decided on this stress ball that was also going to be a great way to try out the multi-material capabilities of this dual nozzle machine. I set the support material to print in PLA because I knew any TPU support on this ball was just going to permanently weld itself onto the model. To do this, you change the material selection in the support settings, and I also set the space between the support and model to 0 since PLA and TPU don't stick to each other. This will also hopefully result in a much better looking bottom surface to the model. I did go one step further and add a raft so that no TPU would be touching the build plate, half because PLA is a lot easier to remove, but also because the bed temperature setting differences between the two types of filament. So this did print successfully, but moment of truth to see if this actually worked, and it in fact did. And that bottom surface is honestly looking pretty incredible, just given generally what TPU normally looks like on the bottom surfaces, since it doesn't really cool very well, and the PLA support was very easily removed from the build plate. Now, all of these prints so far have been excellent, but we haven't really even gotten to what I primarily use 3D printing for, and that is life-size prop building, and more specifically, droids. If you've seen any of my prop building videos, you're probably well aware by now that I refuse to use anything other than ABS or ASA for these projects, thanks to their post-processing benefits. Both of these types of filament require an enclosed printer and ideally chamber heating for the best chance of successful prints. Since the H2D includes chamber heating, I was going to fully put that to the test. Using ASA no less, which while it is supposed to be very similar to ABS, I have always had significantly more problems printing, between edges lifting, from the build plate to delamination. I don't know if it was this specific ASA color, this machine keeping everything nice and cozy, or what, but these prints were turning out to easily be the best looking ASA prints I've ever gotten. You can hardly tell they're 3D printed, the layer lines are almost invisible. I also love using droids as test prints, not just because I have a problem, but because it gives me a lot of different types of object shapes. Some that take up nearly the entire build plate length, some need a lot of support, and in the end, they all have to fit together, so it's also an excellent accuracy and tolerance test. While all of these pieces were looking phenomenal individually, they're obviously going to look a whole lot more impressive when combined together into something that actually resembles a droid. By the way, this is a PK series worker droid. You see them doing maintenance on the battle droids, and I figured Roger back there could use a new buddy. Also, quite a few parts I didn't attach for this test fit, so don't mind the handless droid and also eyeless droid. I'm sure you'll see me finish this guy in a future build video. From there, I wanted to finally start experimenting with the other functions the H2D has, starting with the laser module. The modules actually come in two strengths, 10 watt and 40 watt. I'm going to be sticking to the 10 watt version for this video. First thing you'll find in the box are the safety instructions, which I would highly recommend reading through. This packet also has a couple of calibration cards that we will be using later. And lastly in the box is the laser module itself. With the laser, there are some specifics we need to do to the machine before we start using it, starting with installing the emergency stop button. First, turn off and unplug the printer, then remove the safety key from the back of the machine. The emergency stop button then plugs into that outlet. Now to actually attach it to the machine, there is this space on the side where you just sort of lift up the printer and then tuck it underneath, and that button shouldn't be moving anywhere. Next, we're back to this bag of pieces, and specifically for these ventilation pipe screws. And these are for attaching this vent piece onto the back of the machine around the vent that is actually part of the printer. Next is attaching the hose, and for this you're going to need to grab that hose clamp that was also in that parts bag. You're going to want to make sure that this hose is attached really well around that vent piece, make sure there's no gaps or anything, that the hose is nice and smooth around the edge. and then you can start to screw the hose clamp to secure it in place. From there, you're going to need to place the other end of the hose either outside through a window or attached to some sort of smoke purifier. That should then also technically be venting outside. Now we can actually start attaching the laser module. For ease of access, I'm removing the glass top. It's also a lot easier for me to show you what's going on here. First, you're going to want to remove the plastic covering on the tool head, and then the laser module just sort of slides into place, and then the side lever gets pushed down to lock it and secure it. The cable then gets plugged into the back of the tool head. There's a little silicone gasket covering it that you just remove and then plug the cable in there. And the last thing to attach is the air hose. This goes from the laser module to an inlet that is in between the two PTFE tubes. There's also a space for the tube to click into place for a bit of cable management. And here is a better look at what all of that looks like plugged in. If you took the glass top off, you're going to need to replace that before turning on the machine and beginning the calibration setup. I feel like this is going to be a lot more straightforward on the laser edition, especially because it already has that bird's eye camera installed on the machine. But once you've confirmed on the machine that everything is installed correctly, it's going to prompt you to remove the build plate so that it can start scanning the codes and markers that are on the magnet. Now onto the calibration of the laser module itself. But first we're going to need to set up the laser platform and get all of these slats installed. These slats actually really securely click into place. They're not just sort of free floating, which I was very happy to see, because if you've ever used another laser engraver, then you will know that the slats tend to like going everywhere. You're then going to need to grab one of those calibration cards that I mentioned earlier on in this video and place that in the upper center section of the platform. The machine then does a quick little engraving test onto this card and then afterwards scans it, I would assume, to read the various levels and figuring out exactly the settings that it needs to be applying to its defaults or whatever. And here's what that test card ended up looking like. And with that, calibration is completed. I wanted to start with a project that's been on my to-do list for a while, but I've just never gotten around to it, and that is a leather patch for my armor or helmet bag. Now, there are lots of presets built into Bambu Suite, which is the new software specifically for the laser and digital cutting side of this machine. But because I'm using this random leather scrap, I'm going to start by running a calibration test to figure out the best settings for this material. The software makes it really easy to create your own custom test to use. You can change how many intervals you want and what type of test you want the machine to run, whether that's for engraving or cutting. Pressing capture image will give you an updated look at what is sitting on the laser platform, so you already saw me put in this piece of leather into the machine. From there we can super precisely position this test onto that piece of leather. Because this is more of a custom material, I did measure the leather myself beforehand, but I believe you can have the machine do it on its own. This is so the machine knows where to focus the laser. But once you've got that information input, we can press make, send this off to the machine, and begin the test. Bambu Suite will automatically open a live stream of whatever is going on in the machine, which is really handy because it gives you a much better look at what is actually going on than you can really tell through the green doors. On the machine screen, it also brings up this live stream of that side view camera. Here is how the test turned out. The columns are variance in laser power and the rows are speed. A lot of these swatches are looking quite good, so this is going to come down to a bit of personal preference as to which swatch you like the most and also where you feel the sweet spot is between speed and power. Now that we have these test results, we can start our actual project with this armor bag patch. You can see after doing the capture image, the test that is also part of this piece of leather, so I'm going to try and put this patch pretty close to the test just so I'm not wasting any material. Then in the material setting, I'm going under user defined material and then inputting the values that I want to be using for this piece. And then we can get this sent off to the machine. Now for this first patch, I decided to just have it engrave this design because I honestly wasn't sure if I wanted this to have burnt edges, so I didn't have the machine also cut it out. And here's what that patch was looking like. This turned out so well. I'm so thrilled with how this turned out. A very good first impression for this machine. It captured all of the details so perfectly. After that, I did decide to cut this piece out by hand, and here is what that was looking like. But since this did turn out so nicely, I then went and did another one, and this time did have the machine cut it out, and that once again turned out really, really beautifully, especially considering this was not particularly thin leather. I still had quite a bit of space on that scrap of leather, so I also decided to do one of my logo and again had the machine cut this out. And here's how that turned out. This is almost even more impressive because of all of the small details that this machine accurately captured in this design. So some great first impressions there. But for the next project, I wanted to try combining 3D printed pieces with laser cut material. I've had this collection of Droid pins that I've wanted to display for months, and I thought, why not make a custom pin board for them? I designed this Droid Depot logo board that has the recessed space for us to add some cork into. Now, all I had was some of this 2mm thick cork, so I'm going to be using multiple layers of it to create this pin board. This time I'm importing a DXF file for this design. I exported it from my 3D model, so this is importing in the exact scale that it needs to be. So we're not going to be doing any rescaling this time, but we can place this on the material a little better if we need to, but overall this was looking good. In fact, it pretty much takes up the entire material space. And because there was already a preset for this specific cork, I didn't have to do any extra testing work there, so we can just start getting this cut immediately. Here's a better look at what the video live stream looks like from the printer screen. It's pretty fascinating to see the differences of when you look at this through the door versus what is actually going on within the chamber with that super intense laser beam. And I'm very happy to report that these presets seem to be dialed in perfectly. This did in fact successfully cut, and then I went ahead and did this 3 more times so that there were 4 layers of this cork material. I ended up not cutting the circle out of that main dome section and instead just put them all on the single piece to save material. And once I had the 4 layers that I needed all cut, I could then start installing them into the 3D printed piece. The internet told me wood glue was the most ideal glue to be using for cork, so that's what I went with. Thoroughly applied that all over the 3D printed piece and then started installing the cork. And then repeated those exact same steps 3 more times. And here's what that looked like with all of the layers of cork installed. The fit between everything was perfect, and once I'd let the glue thoroughly dry, I then went ahead and installed all of the pins onto it. And thanks to my procrastination, I now have a cooler pin board than I could have ever imagined. One of the things with this machine is there are a lot of parts and accessories that can really start to take over your desk, so I wanted to come up with a solution to keep everything organized and together. I modified a rugged case to have the Bambu logo cut out of the top because one of the other possible materials to use with the laser is this beautiful bamboo plywood, and it was just too fitting for this video to not use. This is also one of the materials that has the QR code functionality, so when you insert it into the machine, the camera automatically reads what it is and sets it as the material to then be engraved or cut. I have to say, this was super slick and also very convenient. The bamboo inserts fit into the lid perfectly, so all that was left to do was glue them into place, put the rest of the case together with some bolts, and then put all of the extra pieces and accessories into it. I did keep the design completely open inside because I wasn't sure how everything would fit, but I might design a more specific divided version to store everything a little more securely. But for now, this is the perfect solution and exactly what I needed to help me organize all of this stuff. The last thing we need to try out on this machine is its digital cutting function. It also has a pen attachment if you want to use it for any sort of drawing or plotting. This is another module like the laser that gets installed onto the front of the tool head and plugged into that back port. It again has a specific build plate to be used with it, but this one is a cutting mat that has 2 sides, one with a light grip mat installed and the other strong grip. This refers to the adhesive strength that holds the materials in place during the cutting process. Once you've turned the machine back on with the new module installed, it will prompt another set of calibrations. These cutting module ones are actually quite similar to the 3D printing calibrations. It probes the cutting mat in the same way the nozzles do to level the build plate. For my first cutting test, I wanted to make myself a custom t-shirt using some heat transfer vinyl with my profile picture, logo, whatever we want to call this. It's actually my maker coin design that I've just then used for literally everything else. I set this up as a basic cut, and I don't know why part of it's black because this did cut fine, and there is already a heat transfer vinyl preset, so I just used that. For this, I am using the light grip side of the mat, and ignore the fact that I put this vinyl on backwards in this footage. I did immediately correct it, but I guess I never filmed that. So once you've got that installed on the build plate, you can update the image feature, and it will actually automatically mirror the design for you, but I'd already done that, so I just said like cancel on that so it wasn't mirrored back into the wrong direction. For heat transfer vinyl, the side that is facing up is actually the back of of the vinyl, so that's why you need your design mirrored. At some point during this cutting process, it finally hit me all of the material weeding I was going to have to do for this design. Thankfully, earlier I had printed out the weeding tool that's part of the local printer files. The hardware for it is included in the tool pack, similar to how you get the hardware for the scraper in other Bambu Lab machines. So I got all of that put together. Again, had to use some of that Galaxy PLA filament for it. And then I began the grueling process of weeding this design, which weeding is just the process of removing the excess material that you don't want to be a part of your finished product. So basically what would be considered the background of the design itself. Not gonna lie, I think this process took me about an hour to complete. And even though while I was doing this, I had regretted pretty much every life choice I had made up until that point, it did turn out to be quite a good test for this machine because you can see just how accurate and highly detailed this machine can cut. I cut out a couple of significantly more simple design pieces so that I could create this almost collaboration t-shirt, I guess we will call this, and my mom did help me iron on all of this heat transfer vinyl. I honestly don't think she would have let me touch her iron even if I had wanted to do this on my own. And the sheet you just saw us remove was some parchment paper that just protects the iron from the transfer tape. The first transfer was successful, so on to the big design. And here is how the shirt turned out. Also added a little sleeve design, and despite the lengthy process to get to this point, I'd say it was well worth it. Next, I wanted to test the print and cut feature. It's something I actually use quite frequently because I'm always having to make myself Dexcom stickers. They are kind of the bane of my existence though, because I like using this glossy printable vinyl, which is the epitome of what isn't recommended for print and cut because machines don't normally like reading the registration marks on the glossy surface. So I am very hopeful that this will go a lot smoother on the H2D since I believe it uses the tool head cam to read the registration marks, and that will hopefully be more accurate and less dependent on what type of material the design's being printed on. About midway through this cut, it dawned on me that I'd probably made a fatal error on my part. I had gone in and adjusted the pressure settings for this cut because I wanted these stickers to be kiss cut, which means it's cutting the vinyl only but leaving the sticker backing intact. So I didn't have like a million stickers on my hand and they're all still within one sheet that you can just remove the sticker from. But I adjusted the settings for the basic cut and not the print and cut feature, which meant that this still was cutting at full force and cut all the way through the sticker paper. But you know what? Maybe an accidentally good test because it does mean that you can see how accurate it was at cutting all of these little stickers out. This is really one of those times where even though I've put a few hundred hours on this machine, I feel like I've barely scratched the surface in terms of what it's capable of. So I would say consider this video somewhat of a part 1 with more to come. And if there's anything in particular you want to see me expand on or do a more in-depth test of or feature used, please let me know in the comment section and I will look at adding that into a follow-up video. But as always, I wanted to wrap this video up by giving you my final thoughts as well as a rundown of the pros and cons for the Bambu Lab H2D. The first thing that I wanted to discuss is how the other features with the laser and digital cutting modules don't feel like gimmicks. And what I mean by that is in the past when machines have tried to do multiple different things, they don't necessarily do any of those things very well, and it's almost just like a checklist to say that, oh yeah, this can be a 3D printer and it can also be a laser cutter and whatever. But the H2D is genuinely an incredible 3D printer. It is a very capable laser engraver and cutter, and the digital cutting has been working amazingly as well. The software with the cameras and how everything works, even though right now there are a few bugs, but again, technically this is still the beta version of this software, still works really nicely. It's a very pleasant user experience. There's very precise placement and control that you can get when plotting out where you want things to be. Even though I have a ton of praise for the laser functionality on the H2D, I am also very glad to see that it is coming out in the 2 different editions because I know not everyone is going to be into the other functionalities. The standard non-laser edition of the H2D is apparently going to become upgradable though. So if you're somebody that's starting out, you don't feel like you have any interest in using laser for your projects, but then that changes later on, you can just upgrade your original machine. I could see a ton more people being into the digital cutting functionality though, especially considering you don't need any specific specific safety upgrades on your machine for it to be compatible. And if you are also somebody that's super into prop building, I am constantly making myself painting stencils for various projects. And while I know a lot of you have a 3D printer, not as many of you necessarily have the capabilities of cutting out your own painting stencils. And so if you already had a machine that you could just buy a module and a build plate for and then have that technology at your disposal, I think is going to be very appealing to a lot of people. One of the biggest things I was concerned about was what it would be like going from a 3D printer to, say, a laser engraver, and what the user experience would be like when having to add the modules onto the hot end. And it's actually incredibly simple. I would say very user-friendly. I think I was down to like 10 seconds for taking the hot end cover off and then getting the other part clicked on. I think I actually even have footage of me doing it one-handed because I was trying to film with my other hand. So I'm very glad to report that it was a lot more simple than I was imagining it to be, and significantly less of a headache than I was imagining it to be as well. The laser module is slightly more difficult to install than the digital cutting one, just because you have that additional air tube to plug into the back, but overall still a pretty simple process. And I did actually try removing the laser module with the glass top on, and I was successful. I don't think I ever tried putting the modules on without the glass top, normally just because I was trying to film all of the time and it was just not going to be cohesive with trying to film and like show you all what I was doing and how I was installing the things with the cover still being on. But that is the one thing that I would say would possibly start to be more of an issue, is generally everyone stores their AMSs on the top of the machine, and so when you are looking at flipping the machine to then be laser cutting or digital cutting, you might always want to look at removing the glass top just for ease of access to the hot end. And that's where it could possibly start to be a little less user-friendly, because you'd then be looking at possibly moving your AMS system somewhere else. Let's be real, regardless, it's going to be easier to install if you're not dealing with the glass top being right there, but I do think it is manageable to get the hang of installing the modules while keeping the glass top on. Something I don't think I've had a chance to really expand on in this video are all of the safety features that are built into this machine for its laser capabilities. The Laser Edition is of course equipped with the UV blocking windows and door, but the machine also has 5 flame sensors built in, AI camera fire detection, which I will say is maybe a bit sensitive right now, but I would rather it be overly cautious than not cautious enough. It's built with flame retardant chamber materials, and it also has an emergency protocol in place. Excuse me while I read, I just want to make sure that I get this right, but I'm assuming the emergency protocol is put in place when the camera detects a possible fire. When it enacts this protocol, it shuts the vents for oxygen deprivation, it moves the tool head away, and it creates an alarm on the machine, which I can tell you it does indeed do. And it also sends a mobile notification, which shouldn't be necessary because you should be staying with the machine and sort of hearing it blare its alarms right at your face. But again, I'm glad it takes these extra steps in the offhand chance that you're not standing right beside the printer. I suppose this also works as a good accessibility feature in case you were deaf or hard of hearing and wouldn't necessarily know, even if you were standing right beside the machine, that there was an alarm going off, but you would be able to feel the vibrations from a mobile notification. On the topic of the fire detection and protocol, something that I would like to see is the resume feature being improved upon in the future. Right now, there just seems to be a bit of like a delay or miscommunication in terms of where the emergency protocol is enacted and then where the machine decides to resume when you tell it that, you know, it's okay, false alarm, whatever. Because I can see a lot of the alarms being false alarms, which is a good thing, not me complaining again. But when you have these false alarms, it's going to become annoying if you can't easily resume the project that you're working on exactly where it enacted the emergency protocol. The project that I had the most difficulty with was actually the bamboo cutouts for that box. There just seemed to have been this one like a section on the wood sheet that just loved setting off the fire protocol. Trying to get my machine to complete just that straight line for the 2 parts was fun. Obviously it did end up working, but right now it was more challenging than it probably needed to be, just because the resume feature doesn't resume exactly where it stops. Something that's slightly related to the laser setup is all of the automatic vent features, which I can't say is ever something I thought I would be discussing on a 3D printer, but here we are. So that top front one is the one that you're generally going to be seeing automatically opening and closing depending on what you're doing. Opens for airflow and cooling, but it will shut completely down when you're heating the chamber and needing to retain the heat. The back fan technically has vents as well, although typically they will be open, again, unless you are heating the chamber and it's trying to retain the chamber temperature. Specifically for the laser though, the machine automatically opens the top and back vents, but it apparently bypasses the internal filtration for the maximum airflow to go to the external extraction unit, which really is like the perfect example of how this machine seems to be doing like 20 incredibly smart things that you probably have no concept that it's even doing to improve the user experience, or whatever you want to call it. On the topic of the external extraction system, the smoke purifier also seemed to have done an excellent job. Did not smell anything. I have used other laser engravers in this workshop and I can tell you that was not the case. That being said though, regardless of how good the filtration system is, the pieces themselves will always somewhat have that smoky, burning, laser cutting scent. I wouldn't necessarily say it's a bad scent, it's just a very distinct one, and I suppose also changes depending on what you are engraving or cutting. The wood of course smells sort of like firewood, even the leather kind of smelled like that firewoody type of scent, and after using it, the printer interior also does retain a bit of that scent, which brings us to the one downside in terms of the laser module and capabilities of this machine, is that it is going to require more cleaning maintenance due to the smoke residue, although it is apparently designed to be as minimal as possible in terms of residue buildup. It is just sort of like an unavoidable thing that is bound to happen. You can only control the airflow so much, and again, this is going to be very dependent on what you're choosing to cut and engrave. I will be interested in seeing if over time it starts affecting the machine at all, even if I do sort of try and maintain its cleanliness inside by wiping down the various surfaces and trying to make sure that nothing looks like it's becoming a problem on the inside of the printer. I'm not actually sure how much of an issue it will ever really become for anybody though, because I feel like the people that are going to be most interested in this machine for also using its laser capabilities are people that want to have that technology at their disposal for various projects that they're interested in working on, but they're probably not going to be using the laser as its like main function. You know, even for me personally, I do enjoy laser cutting and engraving projects, but I probably don't even do the equivalent of like one a month. I have a feeling I might be doing a whole lot more now because this is so much easier to use and so accessible for me in my workshop that when something does come up, I can just sort of like slip the laser bed into that thing, make sure it's all set up and ready to roll, and just have it create whatever I want it to. And that's actually sort of one of the things that I am most excited to see for the future of this printer, is all of the incredible projects that I'm sure the technology of this machine is going to enable people to create, and also just the general concept of having laser projects be as accessible as 3D printing files and projects to make. You can come for Bambu Lab all you want, but I don't think anybody is disagreeing that they have significantly streamlined the concept of specific projects. Between the Maker Lab supply kits that give you all of the hardware to then add to 3D printed parts to make these super cool projects. I mean, you can literally 3D print a computer mouse if you want, but even just Maker World as a whole is set up that you literally can just press print on anything you see on the website. So having that entire ecosystem already set up to then add the possibility of laser cutting and engraving and then the digital cutting idea, I think is going to be absolutely phenomenal. I think the community there is going to come out with some absolutely incredible projects that I can't even fathom right now, but I cannot wait to see. And along the same lines of there being all of these pre-set up projects, it's going to make laser so much more accessible to people, especially with all of the presets built into this machine and its ability to read the specific materials if you're using Bambu Lab's own, which I have to say, it was very nice to not have to do a test for every single material that I wanted to use. It is set up that it's very easy to be doing those tests when you want to use a more unique material to figure out the best settings for it. But you know, not having to do that every time is also really nice. Hopefully we will see presets for even more materials to become available, more so on the digital cutting side of things. You saw my slight fiasco with my Dexcom stickers. I know technically my little mess up there, but it would be nice to see a setting be added for when you want the vinyl to be kiss cut and not cut all the way through. So just little improvements like that. This is more of a note rather than like a pro or con, but anytime you shut the machine off with the laser module or digital cutting module installed, it does have to do a little bit of a calibration before allowing you to use the machine. Both of them only take a couple of minutes. Really, they just sort of like scan and figure out exactly where the module is in terms of like the rest of the machine, I would say. The digital cutting one does probe, or I guess like re-level itself. So just something that I wanted to mention if you are working on a project that you know you're going to be cutting or doing whatever with the same tool like within a certain amount of time, that maybe just leave the machine on, don't turn it off, or else you will be going through this like pretty short calibration, but you know, still a calibration that could become a little annoying if you're expecting to sort of just like turn the machine on and get going straight away. The one slight con, or I guess wish specifically, that I would have for the laser edition is I wish the emergency button would have been able to be built in somehow. I would imagine there are some specifics that you have to adhere to when it comes to an emergency button for laser cutters, and so realistically the only place that I could kind of see that specific type of button, if it had to be a particular size and color, would kind of be along the front of the machine, which if they had done that, I think everyone would have started complaining that it was like an eyesore. So it's one of those things that I'm kind of on the fence on, because I can understand possibly why it wasn't built in, but it also would have been great to see if it was. It would have also been really awesome to see RFID readers on the side of the machine where the external spool holders are. There are just so many RFID readers everywhere else, like on all of the AMS units and everything, that it just feels like a bit of a miss that they didn't also add them there, considering Bambu Lab printers and just generally kind of all 3D printers nowadays really want to know exactly the type of filament that is in each slot, wherever that is, whether that is an external spool or within the AMS. And while yes, the RFID system is only compatible to Bambu Lab filaments, at least for right now, it is a little annoying when you are in fact using a Bambu Lab filament in the external spool and still having to manually input the type and color of filament that it is. So when there are these like little things that just aren't quite there or are forgotten, it feels like extra off, considering like literally everything else has been so well thought out. And this is especially true when it comes to my next point, and that is the AMS HT's cord needs to be longer. As you can see on mine, and I'm sure for the majority of people, especially given that there is the space for it, you're going to want to put your AMS HT on the top of the machine. So it has about the same 4-foot length cord as the machine itself has, except there is about a like 2.5-ish foot difference between where those two cables are plugged in, which then compounds to there being about a 2.5 foot distance of where those two things can plug in if you're attempting to plug them into the same thing. So right now I have my machine plugged into a battery backup that is on the floor, but there would be absolutely no way in getting the AMS HT plugged into that. When I did have the AMS HT plugged in, I literally moved the battery backup onto the desk. This is of course something that is pretty setup dependent. You know, if you had counter height outlets, you could very easily probably get both of those things plugged into the same location, because it would sort of split the distance between the cords. But it is again just one of those things that this machine has everything else so meticulously thought out that when something is off, you feel it even more. The power cord is actually quite standard, so you possibly could get a longer replacement for it. So hopefully that is something that Bambu Lab will consider, shipping the AMS HTs with longer cords. Since I did just sort of briefly mention the battery backup, another note that I have for this printer is its average power draw is over 1000 watts. Now I think that's a bit of like an overestimated, like compensated range, because this machine is capable of doing so many things, like when the laser's going, or when you have the bed temperature, chamber temperature, and nozzle like cranked up to the highest amount. Obviously that's a significantly different power draw than if you're just like printing some PLA, but it is just something that I wanted to note, because if you are like me and do like putting your machines on battery backups for peace of mind and whatever else, most battery backups are rated at like 900 or like max 1000 watts. that's just not going to really work well for this machine. This is something that I have mentioned in other printer tests, so I wanted to like keep it uniform across the board because I know a lot of you are also into plugging your machines into battery backup. So for my peace of mind, I did go and purchase a stronger battery backup, and that has been working great for this machine. Some other features that I probably have not had the opportunity to mention in this video yet, just because they're kind of features that just don't really come up naturally in conversation. This machine actually has 4 cameras in it. You probably can quite easily guess the 2 main ones. The live view camera, which is the one on the side that captures all of the time-lapse footage and what you're generally seeing when you're looking at monitoring the printer. The other obvious camera is the bird's eye camera for the laser and digital cutting and placements and view of all of those parts. It also has a tool head cam that I'm assuming is what it uses to scan the print and cut pieces, as well as some of the other codes on the build plates to say that the correct one is installed and stuff. And there's also a separate nozzle camera to help with print detection failure. You know, the nozzle cam can tell if it's printing in midair, if there's like clumping on the nozzle, all of that kind of stuff. It is also really nice to see that both new types of AMS units have drying capabilities. The AMS2 Pro can go up to 65 degrees Celsius and the AMS HT goes up to 85 degrees Celsius. They also automatically have vents that open and close depending on what mode it's in. It will close everything off when it needs to keep the dry air in. And I'm also very happy to see that the original AMS unit that works for the X1 and P1 printers is compatible with this machine, and the new AMS units will become compatible with the X1 and P1 printers in a future firmware update. Because I know for a lot of you, the drying functionality possibility for the AMSs is something that you've been really hoping for a long time. So I'm very happy to see that Bambu Lab did decide to make the AMS2 Pro compatible with the other machines. The H2D is also apparently compatible with 4 AMS units, as well as 8 AMS HT units simultaneously. I'm not entirely sure right now how that is meant to work. I'm assuming there's going to need to be some sort of filament hub situation going on. Just another thing to know, I guess. Overall, I'm also pretty happy with the layout of the machine. Nothing feels super awkward or misplaced. Yes, there are quite a few things on the back of the printer, so depending on the version that you're looking at getting and the types of things you plan on using it for, it might be ideal if you have reasonably easy access to the back of the machine. I'm definitely a big fan that they didn't put the external spool holders back there and that they're more along the side of the machine. With that one PTFE tube sort of attaching to the external spool holder, it made for very easy access in feeding larger kilogram spools just right on in there and having the larger spool on its own holder beside the machine. I feel like print quality isn't even something I need to mention at this point because obviously it's been incredible, even using some of the most difficult to print with filaments, and the fact that I could print those shoes as my first TPU print and them turning out as well as they did, I was very impressed by. Another one of those slightly hidden features that you probably don't even realize it's doing, but it's actually improving your user experience, is just how insanely accurate this machine is. With that vision encoder plate and the calibration that it does, it's supposed to be able to achieve 50 micron motion accuracy. I know is a bunch of numbers and nonsense to a lot of people that they don't necessarily care about, but just know that it's supposed to be extraordinarily accurate and improve the overall fit accuracy for the pieces. This is one of those things that I really want to look at testing more thoroughly in the future, because really the only project that I had that I could tell you what the fit was like in terms of like pieces together and how accurate it was on this guy, and he went together flawlessly, so I guess I did have a decent test. There were some pretty crazy shaped thigh pieces where you had to like slide this like sleeve over the main thigh part, and I did not think that that was going to go very well for me because it was a very specific shape, and it's kind of one of those things where you would assume you possibly need to be doing a little bit of sanding or filing to get it to fit together well, but those things just slid on beautifully. So I guess I did have a decent test in the Droid, but it is something that I would like to focus on and do more specific tests for to truly see the like level of technology that has gone into this vision encoder plate and like all of the calibration settings and all of the like behind the scenes stuff that it is supposed to be doing to make it as accurate as it should be. And with Bambu Lab's focus behind the technology to make this 3D printer so incredibly accurate is actually why I think this printer isn't larger, or at least one of my theories. The other reason is the sizing for some of the other features. You know, it's pretty standard that for especially the digital cutting, you have those mats be like 12 by 12 inches or 30 by 30 centimeters, which is what this printer is. And this is not like an official reasoning or statement. This is just my theory based on all of the specific features that this machine has and the technology that they've decided to build into it. It seems like Bambu Lab really wanted to have a super heavy focus on high accuracy and have it be a super heavy duty prosumer printer. You know, its build volume is still technically a helmet class size printer. It will generally be the height where you will start to see pieces not fitting. So personally, I do think it would be nice to see them go even taller for build volume, especially because this machine already isn't a cube build volume, so it's not like you want to like keep the number rounding all nice and even. But again, it's one of those things, if the main purpose of this machine was it being so highly accurate, and the way to do that and have all of these other incredible features was keeping it the size that it is, don't make this printer something that it's not trying to be, is I guess the point that I'm trying to make here. Something that I always like to touch on in these videos is the availability of replacement parts. Now, because this machine is not actually out yet as I'm recording this video, I can't speak to the specifics in terms of replacement part availability, but I can say that Bambu Lab has one of the best track records in terms of replacement parts. So I can only imagine that the various components will become available to be purchased separately if anything is needed to be replaced. I was actually specifically a bit concerned over the replacement functionality for the cutting mat, because it effectively is like a spring steel printer build plate with the sticky sides. Like, are you gonna have to like buy this kind of excessive build plate anytime you just want to replace one of the sides? But it seems like the sticker sides actually come off of the build plate, and that will be the part that is replaceable. Overall, I had a great experience using this machine, and it is another incredibly impressive release from Bambu Lab. It's gonna be great for anybody that does a lot of multi-material work thanks to its dual nozzle system. I'm sure the high accuracy is going to appeal to anybody that is into manufacturing parts, especially ones that involve non-3D printed pieces and needing all of those components to be able to fit together seamlessly. The laser edition specifically is going to be fantastic for people wanting to branch out into laser projects. Also for anyone not wanting multiple machines or having the space for multiple machines to create all of these different types of projects. I know this has been an incredibly long video, so if you've made it this far in, thank you. I really tried to cover all of the features and be as thorough as I possibly could, but even then I've probably accidentally overlooked something. As always, if you've got any questions about the H2D on something that I maybe didn't expand upon enough or just completely forgot to mention, please feel free to leave those in the comments. If you want to find out even more information about either version of the Bambu Lab H2D or any of the accessories, there will be links in the description box, as well as links to any of the models that you saw me printing in this video. But that is everything. So thank you so much for watching, and I will see you in my next video.